Welcome everyone to today's discussion on network performance. My name is Brad Howarth and I'm delighted to be here. Now more than ever we are coming to understand the critical role that computer networks play in modern organisations. When they're not performing at their best, there's a good chance that neither are we. But with demands on networks increasing, how can we ensure they're performing to the levels of reliability, throughput and security that we expect? So I'm pleased to be joined now by Yedu Siddalingappa, Product Manager at Mist Systems, a Juniper Networks company, to talk about how Juniper Networks and Mist are bringing some novel thinking to the network performance challenge. Yedu, thank you for joining us.
Thank you, Brad. It's a pleasure being here.
So Yedu, what makes Mist so different to every other wireless network solution out there?
What makes Mist unique is three key things: our SLE-driven operations model, our AI capabilities, and our microservices architecture. So let me take some time to explain these three things in more detail. So when we talk about SLE-driven operations model, when we log into Mist dashboard, so what we see is not about how many clients are connected, how many access points are connected, how many are up or down. Rather, we see service level expectation metrics of the clients in real time. So that means for all the users connected on the Wi-Fi network, are they getting the proper throughput or not? Are they connecting to network in a timely manner or not? Are they getting proper coverage or not? So these are the kind of metrics we are measuring in real time for all the clients, and we are able to show in the dashboard as a SLE metrics. So we have completely flipped our operations model, from device-centric to user experience-centric. Second part is the AI operations. So we use extensive AI capabilities in order to proactively identify and rectify the issues. Since we are collecting a lot of data about the users and the clients, in fact, we collect almost 150 state information of every Wi-Fi client every minute, right? So with that amount of metadata collected, we apply AI algorithms and we are able to identify the problems in a most granular fashion and rectify in fastest way possible. And the third capability is our architecture itself. So unlike most of the other vendors who rely on monolithic common code-based architecture, so we use microservices architecture. So this gives us agility in order to quickly roll out any bug fixes or any new features. So that way we have tremendous feature velocity compared to any other vendors in the market.
Now we've dived right into the product technology, so maybe let's take a step back for a moment. Yedu, can you tell us a little bit about the history and the thinking that led to the creation of Mist?
Talking about the history, Wi-Fi really took off after 2003, when Intel started putting Wi-Fi chipsets in all their laptops. And most of the major Wi-Fi vendors we see today, they were born in that period between 2003 and 2007. The problem is, during that era, between 2003 and 2007, there were no iPhones, there were no web services like AWS, there was no BLE, and even the AI was in a very nascent stage. So most of these modern technologies, they were not able to utilize. So by 2014, Mist founders kind of realized that the existing architectures of other vendors at that time were not able to meet the challenges of the next decade. So they came together and they built Mist by using all the modern technologies available like microservices, AI, BLE to take Mist to what it is today. And when they started this Mist systems, they interviewed a lot of IT experts and Wi-Fi frontline operators, and they tried to understand what are the key problems which is affecting them. And it boiled down to three key things. So one is all of them wanted their network to be more stable. So that means they wanted more tools to proactively identify and rectify the problem. Secondly, they wanted more automation functionalities because the IT teams were getting smaller and they were asked to do more with less. And third, they wanted network to be more business relevant rather than just doing the connectivity aspects. So with these technology tools and with these requirements in mind, Mist was formed. So we made our infrastructure 100% API supported. in order to support all the automation needs. And we have microservices architecture in order to make the code more stable and more agile. And also our access points is integrated with BLE and IoT on top of Wi-Fi. So this enables many more use cases other than connectivity to meet the needs of not just IT, but also the LOB and other businesses.
So let's dive into one of those aspects in a little bit more detail then. You mentioned AI. How does the use of AI enable Mist to solve common problems in a different way?
There is an interesting book called Singularity is Near by Ray Kurzweil. So in that book, the author claims that AI is the destiny of humans and the mankind, and AI is inevitable. I'm not claiming that. So what I'm trying to say is, at least for IT, AI is very, very critical because IT systems are becoming very complex nowadays and the IT teams are shrinking. So people are made to do more with less resources. So Mist and Juniper, we are pioneering in the use of AI for the IT operations.
Mist applies wireless expertise to the data using domain-specific classifiers. These are used to set, monitor, and enforce service levels that measure the Wi-Fi experience. Mist uses various data science techniques to analyze the data and provide actionable insight. Supervised machine learning correlates events for rapid root cause identification. Time series anomaly detection spots negative trends and determines the magnitude of their impact. Mutual information and Bayesian inference correlate metrics in order to identify the root cause of an issue.
We are performing 3 broad functions with AI. One is measuring user experience in real time and quickly identifying the issues in the most granular fashion. Second is we have built a virtual network assistant called Marvis, which basically acts as a Google kind of interface for network operations. Instead of typing all the CLI commands, telnetting into different boxes, we have one dashboard, like a Google, where you can type in commands with English, and then you can manage your network. And the third is self-driving networking model. We have got feedback from several customers that if you are able to detect the problem proactively, and if it is repetitive and if it is automatable, so why not fix it? Why bother report that problem to IT operations? So that's what we have done. So we have slowly started automating the fix for some of the most common problems, and we are slowly taking our journey towards self-driving network. So these are the 3 key things which we're doing in the AI journey.
Another factor that you mentioned earlier was cloud enablement. What does that deliver for you?
We are hosting our service on AWS. So all the benefits of AWS, like security, global footprint, and state-of-the-art cloud infrastructure, that comes naturally on the Mist platform. And also the benefit of cloud is OpEx reduction, because some of the mundane tasks like hosting your server, taking the backups, and building redundancy, so all these things are outsourced to the cloud provider, right? So end of the day, the main benefits for the IT team is OpEx reduction and more time to focus on the core business functions rather than the mundane tasks.
Now, you've also mentioned that Mist is built on microservices. What impact does that have?
The single biggest benefit of microservices is the agility and the stability of the platform.
Over time, more and more features were added to the controller's common code base, creating interdependencies that greatly increased the complexity of the software. Development and testing cycles became longer, engineering teams got larger, and software bugs grew out of control. This all changes if your platform is built on the modern cloud. Complex applications are now split into core functions called microservices, each of which are designed by a small and focused development team. Services are designed independently of one another using optimized technology stacks chosen specifically for that service. Adding or removing features is simple, and bugs are fixed in near real time without network disruption. Services scale up or down elastically when they're needed.
Monolithic architecture, there is a common code base on which different services are built. So as you add more features and more bug fixes into these services sharing the common code base, they become more and more complicated and the overall code becomes more and more fragile. But in a microservices architecture, we treat every network service like an individual service. All of them are running independently, connected by a common bus. So that means any bug fixes or any new feature can be done on an individual service rather than touching the entire code base. So that makes the code very, very stable. And also it enables us to roll out features very fast. So all the services can work independently by a more agile, small focused team. So this helps us to come out with firmware updates or bug fixes very, very fast compared to other vendors. For example, we are releasing new firmwares on a weekly basis. Every Wednesday, we have a new firmware going out.
Now, when you were talking about AI, you mentioned Marvis. So what is Marvis and what does Marvis do?
If you are an Avengers fan, you might have heard about Jarvis. Marvis is AI component, which is inspired from Jarvis.
Marvis Virtual Network Assistant is the holy grail in AI-driven IT. In responding to simple natural language queries or providing root cause analysis for issues, Marvis VNA uses information theory to analyze massive amounts of data and draw subtle inferences. This information is correlated across a global knowledge base to determine the scope and magnitude of a problem.
So it basically gives natural language interface for network operators to manage the system. Marvis still cannot operate like Jarvis in terms of accepting voice commands and all, but it can accept English commands typed on a chat window, like troubleshoot my client, find out who are the unhappy users in my site, or get a list of all the users who are present on this particular floor between this and this time on this particular site, right? So these kind of commands, we can enter, and Marvis, which is our AI engine in the background, which goes and troubleshoot and perform all these functions.
So looking at all of that together then, what are the differences that I'd notice as a user on the network?
So we are talking about two types of users here. One is the end users and other is the network operators. So in terms of end users, the benefit translates to reliable network service because IT operators can proactively identify and troubleshoot the problem, and there is less downtime because our cloud infrastructure can perform some of the things like firmware updates automatically in the cloud, which is completely transparent to the users. And the third is security. Since the firmware updates happen very fast, so that can take care of any security issues or the bug fixes. So that gives better security for the end users. And for the network operators, definitely they feel more empowered. So they have more tools at their disposal now in order to measure the user experience and also to understand the problems and rectify that.
So what does that actually mean then for the people that are managing the networks today?
The benefit of IT team is they can do more with less. So with the AI and automation capabilities, now we don't need a large contingent of users to manage the network. So only like few team members are enough, and IT team can better utilize the workforce with high value-added tasks.
So that's a lot of capability in terms of network management. In terms of putting it to use, does it start to enable us to do things that we couldn't have done before?
Certainly. See, IT today is seen not just as an enabler of connectivity. So people are expecting more from the network. IT is becoming more driver of business solutions. Just to give an example, especially in this COVID-19 scenario, many industries and many manufacturing entities, like who are operating even during this shutdown period, so they are interested in contact tracing solution. So they want to trace the people and they want to identify if there's any infected person and which are the areas they moved within the venues, and also identify the people who came in contact with that COVID-19 positive people, right? So these kind of solutions can be enabled from our infrastructure because we not only support Wi-Fi connectivity on our infra, we also support BLE-based asset tracking and people tracking. So this kind of enables many other use cases like customer experience solution. Now we can have a mobile app which is location aware, and we can roll out solutions like indoor location tracking or giving notifications to the customers who walk into the mall or a hospital or a hotel, these kind of environments. So the use cases are kind of endless once we start integrating the intelligence built into the network with the business applications.
So can we see it in action?
Certainly. So this is what we see when we log into the Mist dashboard. starting with SLEs, the service level experience of the clients, some of the AI capabilities like natural language interface, and the Marvis action, which is our self-driving network part, and finally the location piece. Coming to SLEs, so this is the dashboard what we see first when we log into Mist. Here we can see SLE is defined for wireless network, wired network. We can choose the site and we can choose the duration. And these are the metrics we are defining, which quickly captures how is the user experience on the network in terms of speed of connection, in terms of throughput, coverage, roaming, and other aspects. We can set the SLE metrics here. So in this case, for example, we have set time to connect as 2 seconds. So all the users should get connected to network within 2 seconds or else they fail the SLEs. You see like a lot of errors in this particular network. That's because we have purposefully inserted some errors, just for the demo purpose, just for your information. Let me go to this successful connects. We see that the success is only 60%. Let's try to drill down and identify what is the issue. Looks like authorization is causing most of the problems, almost 96%. So let me drill down a little bit. Here we can see how the problem is distributed across the users, across the access points, and we can see the timeline of the distribution of errors, the time during which the maximum error was occurring. And it also shows at that particular time, was there any config changes made or was there any optimization done by the network? So this kind of helps in further troubleshooting. And we can also see the distribution of the errors across the access points, WLANs, device types. And we can also see the most affected items in terms of users, access points, and application. So let me see here. For the users, the most affected user seems to be this particular client, which is Mist Pi 15. Looks like this is a IoT device, which is being used in the testbed. So let me drill down further. It kind of gives a summary of the issue. The summary states, okay, the failure is client specific and most of it is happening on a testbed SSID, testbed access point, and this particular WLAN. So I can go further down and look at even the events associated with this error. So as I said earlier, we are collecting close to 150 state information of every client every minute. And we filter out all the bad events and we even do a packet capture, at that particular error situation. So in this example, whenever the authorization failure happened, we have even captured the packet. So this kind of shows the power of Mist platform. So we have eliminated most of the level 1 support with this kind of a workflow. We can identify the issue, we can identify the root cause, and we can even do the debugs and packet captures to quickly identify whether it's a config issue or a firmware issue or anything associated with other devices, like apart from the Wi-Fi. So that's about SLE dashboard. So let me go back to the AI capabilities. I'll start with the natural language interface, which we call it as a Marvis. You can see some of the commands here. So you can type all these commands in simple English and get most of the network operations tasks done from this dashboard. Let me try to run some commands. Say locate a user. In this case, username is Denali. So it shows where the user is located in the network in terms of site, floor plan, and the AP and the location. So like that, we can say unhappy users today. So who are the clients having problems today? So it shows up a bunch of clients here, and we can drill down from this dashboard and identify the service levels and perform like various other functions. And we can perform even the troubleshooting aspects from this dashboard. Here I'm troubleshooting this user Denali. So it looks like most of the things are good, but it looks like one access point was being rebooted for some reason. And if we investigate further, we can look at the service levels, classifiers, correlations, and many other things, like which helps in quickly root causing the issue and taking some resolution actions. So that's about the Marvis. And we have taken this AI capability to the next level, which is what this Marvis Actions is all about. So Marvis Actions does not wait for the users to enter the command like troubleshoot the client or troubleshoot this particular network. It proactively hunts the problem in the network and it shows up what actions need to be taken in order to rectify. And this runs across multiple elements of the network. So in this example, for the switch, it has identified 5 actions. 3 actions are related to missing VLANs. So some of the ports are having missing VLANs and there's a bad cable situation and there was a negotiation mismatch. And we can even assign these kind of errors to some other IT person to drive the actions. So that's about Marvis. And finally, the location piece. So as I explained earlier, so missed access points not only includes the Wi-Fi capability, but also has BLE and IoT capabilities as well. So BLE is a very interesting piece, which can give very accurate location in a fast and timely manner compared to any other technologies, especially, related to Wi-Fi. So in this example, we are seeing the dashboard or the floor plan rather. And on the floor plan, we are able to identify the location of 4 different network elements. We can see the Wi-Fi clients, which are identified in purple, and we can see the mobile app clients, which are using pure BLE for location tracking purpose. And we can see the beacons. We have this patented capability called virtual beacons, which we can insert on the floor plan and we can drive location-specific engagements. And finally, the assets. We can also track the assets which are tagged with BLE tags. And going forward, we are planning to add other elements of the network like SD-WAN, security. So this way, we have complete AI-driven networking to take care of the entire enterprise IT elements.
So what does the acquisition by Juniper Networks mean for the product roadmap?
I would say acquisition of Mist by Juniper is like a perfect marriage. So we both have non-competing kind of products. And also both Juniper and Mist kind of believed in AI-driven networking even before the acquisition. So there was alignment of vision and there was alignment of products. So going forward, our vision is to bring the AI capability which is present on the Wi-Fi networks today to all the other elements of the network, whether it is wired, SD-WAN, or security. So we have already integrated the wired stack of Juniper on our Mist AI platform. And going forward, you will see SD-WAN, security, and many more things, which is truly exciting towards the vision of AI-driven networking.
So why should Mist impress business leaders outside of the IT function?
Nowadays, IT is seen not just as an enabler of connectivity, it is also seen as a business enabler. So, for example, in a healthcare facility, Wi-Fi network is not just used for connectivity, it is used for guest access in order to improve the patient experience. It is used for asset tracking in order to track the critical assets and also to improve the visitor experience in terms of like indoor wayfinding within the hospital premises. So there is a lot of intelligence present within the network, whether it is location intelligence or the presence, who is connecting to the network, and the identity. So all this intelligence we are able to expose using our APIs, and this kind of enables many other use cases, right? So which is applicable to many other industries.
Yedu, thank you for sharing your insights.
Thank you, Brad. Thanks for having me in the discussion.
Well, that's it for today's discussion. Certainly a lot of interesting information there and an exciting future ahead. For viewers out there wanting to know more, please follow the link that is about to appear on screen. Otherwise, stay safe and we look forward to seeing you again soon.